let's go ahead and start on note 6. So note 6, I'm going to talk about the relationship between confidence intervals and significance tests. So think of this notes as like a giant recap. So if you want to go back and let's say you're struggling on the Desmos portion, all the Desmos stuff I'm going to do right here in this notes. So 6.6. So first we're going to look at a problem in order to compare what it means to find a confidence interval versus what it means to do a significance test. So it says a recent study suggested that 77% of teenagers have texted while driving. None of you guys, right? Right? None of y'all. Okay. A random sample of 50 teenage drivers at the school was taken and 33 admitted to texting while driving. Assume all conditions have been met. Use your calculator to answer the following. So the first thing it wants us to do is construct a 99% confidence interval to estimate the true parameter of teens who text while driving. So the first thing we're going to do is we're going to identify our successes and our sample size. So what is our number of successes? 33. What's our sample size? 50. Okay, the next thing I'm going to write is my confidence level, which we see is 99% or 0.99. Okay. And then in order to solve this is at this point, we need to go to Desmos. So I'm going to go ahead and open up Desmos. So remember, in order to solve this, we go to inference. And then on inference, what are we clicking? Z-test for proportions. And we type in our successes and our sample size. So 33 and 50. I hit create tests. And then I'm looking at a confidence interval. So I make sure I click on that drop down. And then for confidence level, I put 0.99. So when I do this, I get the interval 0.487, 0.833. Everyone should be writing on the notes, focused on the notes. And so from here, we would then write our conclusion. So remember, the sentence stem for confidence interval starts off how? We are 99% confident. I did that, confident. That the true proportion of teens who text while driving is between 0.487 and 0.833. Okay, so now using this same information, we're going to answer part B. And part B says, conduct a significance test to determine the proportion of teens who text while driving and is different than 77%. So this part right here where it says is different, right here, is different. Does this tell us we have a one-sided or a two-sided test? Does it tell us direction? No, it doesn't tell us direction. So this is a two-sided test. If it said less than, greater than, bigger, or smaller, then we would know it's a one-sided test. So this is just a two-sided test. So our information here is going to stay the same. The only thing that's different is that since we're doing a significance test, we're going to have our hypothesis. So we have our null hypothesis is P is equal to 0.77. And our alternative, since we're just asking to see if it's different, it's going to be not equal to 0.77. Okay. Our successes is still 33, and our sample size is still 50. Okay. So since we already have the inference up with that same data, I'm just going to click on the significance test, scroll down, and type in my null hypothesis. So what number am I typing in here? Yeah, 0.77. And then I need to make sure that my tail is on what? Both, right? Because it's a two-sided test, so I need to look at both sides. And so what this gives me is it gives me my p-value. So my p-value is equal to 0.065. And I'm supposed to be comparing that p-value to what? What variable do I use? Alpha. And in this case, what is alpha? Good, 0.01, that 1% significance level. So now that I have all this information, I'm comparing p-value and alpha, and what am I noticing? Is p-value bigger? Is p-value smaller? It's bigger. So I'm going to start it off. Since the p-value, which is equal to 0.065, is larger than alpha equal to 0.01, do we reject or fail to reject? Fail to reject. So we fail to reject the null hypothesis. So if we fail to reject the null hypothesis, do we have convincing evidence or do we not have convincing evidence? We do not. So we'd say we don't have convincing evidence that the proportion of teens who text while driving isn't different than 0.77. Okay, we don't have evidence for that. So that's why I'm saying isn't different, because the original alternative hypothesis is that it was different. Okay. So now what we're going to do is we're going to compare what each of these inferences gave us. Like, what did the confidence interval tell us, and then what did the significance test tell us? So for the confidence interval, it gave an interval of all plausible what? New population parameters. Gave us all plausible population parameters. So it's saying somewhere between about 49% and 83% is the amount of actual teens who text while driving. Okay. Versus our significance test said that 77% is a possible value for a population parameter. So 77% is a plausible value for population parameter. So confidence interval gave us an interval of plausible values. Significance test just gave us one possible value. Okay. If we look at that 77%, would you say that that is inside or outside of our confidence interval? It's inside, right? So we can say our confidence interval contains 77%, which means that it agrees with the significant test. Okay. So if it agrees, which means the interval is inside, then we would say that we failed to reject. Okay, so the whole point of here is saying, okay, we now see a connection between the two. And the reason why we see a connection between the two is based off the next part here. So look, it has confidence interval, shaking hands with significance tests. Okay, we can only say that they are equivalent to each other if the confidence interval and significance tests total up to 100%. So for example, if we had a 90% confidence interval, that would be the same as finding a what percent significance level. If we have to add them up to 100, 10. Okay. So if we look at the next one, if we have a 5% significance level, that means what is our confidence interval? 95. And if we have a 99% confidence interval, what is our significance level? 1. So based on the problem we just did, were they equivalent? Yes, because what was our confidence interval? 99. What was our significance level? 1. Could we mix and match and say that they have anything that's equivalent? Like, could we do a 99% confidence interval with a 10% significance level? Would we be able to compare that data at all? No, because we're looking at two different things. Okay. So it says if the confidence interval contains the null hypothesis from a two-sided test, we fail to reject the null hypothesis. So if the confidence interval contains the null hypothesis versus if the confidence interval does not contain the null hypothesis, okay, we are going to reject the null hypothesis, which means we could end up using a given significance level or a given confidence interval, and whether or not that significance level or that p-naught value is within the confidence interval, we could say reject or fail to reject without completing the entirety of the test. So here's an example of that. Okay, so in this example it says Scott's Turf Lawn Builder makes the claim that when a user plants their grass seeds, 88% of seeds will germinate. The germination rate of seeds is defined as the proportion of seeds that when properly planted in the fertilizer, watered, sprout, and grow. The company regularly tests this claim to make sure its product is efficient. They plant 500 grass seeds in their fertilizer and find that 412 of them germinate. Assume all conditions are met. So part A wants us to find the 95% confidence interval, which means we would first have to write the number of successes, which is 412, and then the sample size, 500, and then our C percent is 0.95. Okay. So from here, we can go straight to Desmos and find out what that interval is. Okay, so I'm going to open up Desmos again. And I'm going to go, same thing, add an inference, z-test for proportions. Okay, my successes was 412, and my sample size is 500. Okay, I'm doing a confidence interval at 95%, so 0.95. So this gives me an interval of 0.791 to 0.857. Okay, so one thing I did notice that I'll talk about a little bit that happened on the FRQ that you guys just did is in your calculate portion, you guys put way too much information. Okay, and or you tried to solve it by hand. Okay, When you tried to solve it by hand, a lot of you guys were off by a few decimal points, and those decimal points are going to matter, okay? So my suggestion to you is if you really want to write the formula and plug everything in, that's great, do that. But go to Desmos to get your exact answer, okay? Just because we don't want you getting marked off if your algebra is wrong. Okay, so continuing here, it says, suppose the company conducted, so let me get rid of this real quick. Suppose the company conducted a test of the null hypothesis being p is equal to 0.88 against the alternative hypothesis that p does not equal 0.88. Is this one-sided or two-sided? Two-sided. Using alpha equal to 0.05. Use the confidence interval to determine whether this test would reject or fail to reject the null hypothesis and explain your reasoning. So what we need to do is we need to see if our p naught value, which is 0.88, is inside the interval. So would you say yes or no? No. Is 0.88 is greater than that 0.857, so it's outside of the interval. So we would say that since 0.88 is outside of our 95% confidence interval of 0.791 and 0.857, we what? Going back up to the back up to the notes, are we going to reject or fail to reject? We are going to reject, because if it is not in the interval, we reject. So we're going to reject the null hypothesis. So if we reject the null hypothesis, do we have convincing evidence or do we not have convincing evidence? We have convincing evidence. So we have convincing evidence that what? So remember, we look back at the alternative. And what was the alternative hypothesis? It's not 0.88. So we have convincing evidence that the germination, remember we have to tie back to our context, our germination rate of seeds is not 0.88. And then the last thing on this notes here is to find the p-value for this test and then interpret it. So in order to find our p-value, if I open up Desmos and go back to the inference, so I go back to inference, z-test for proportions. It should already be up for you guys. It just closed out for me. So I need to type it back in. So 412, 500. 0.95. If I click on these three dots right here to the side, or sorry, not those three dots, go to significance test. Right here, the p-value. Our significance test was the null of p naught of 0.88. Sorry, right here. So you would type in your 0.88 because that was your p naught value for your significance test. And we would make sure we're looking at both of the tails because this is a two-sided test. And we see that our p-value is equal to 0.0001. And remember, p-value is the probability that this will happen. So is this a good probability or a bad probability? Bad, right? It's saying you have a 0.0001, well, a 0.001% chance of something like this happening, which is a very, very small percentage, okay? So this ties into whether or not our p naught value falls within our confidence interval. Well, since we said it fell outside of that interval, it makes sense that the probability of that 0.88 happening versus not happening is going to be very low because it's not in our original confidence interval. So let's say I change this and instead of 0.88, it was like 0.8. Okay, would 0.8 fall inside of that interval? Yes, so we can make the prediction that the p-value is going to be much higher, right? Because it's inside of the interval. So our interpretation of this is that the probability that 412 seeds, the probability at 412 seeds of 500 will germinate if 88% actually germinate is 0.0001. So very, very low. The probability that 412 out of 500 seeds will germinate, if 88% of them actually do, so remember this is our prediction of what would happen versus if it actually happened, is very, very low.